Welcome to the ArcGIS Survey123 Field Data Collection with SmartForms session. I'm Barbara Webster, and also presenting with me today are James Tedrick and Zach Sotheby, and we're product engineers on the Survey123 team. Today we'll show you how to configure maps for your survey, work with external GNSS receivers, and model inspection workflows. Many surveys include a map or multiple maps to collect geopoints, geotraces, or geoshapes, and there are several ways the survey author can configure these maps. One way to use a custom map in your survey is by using linked content, which allows you to link a hosted map that has been configured with any layers, symbology, or labels you might need to provide the best context for the data you're collecting. To provide an example of how to link content in a survey, I've created and published a survey, and I've also created a web map that I want to use in my survey instead of one of the default base maps. To link to my custom map, I'll open the survey in Connect, go to the Linked Content tab, and search for the web map that I've just created. Once this map has been added to the Linked Content menu, I just need to reopen my survey in the Field app, and the linked map will be available as one of the options in the Base Map Chooser. Linking content in this way allows you to manage and organize your maps. A few things to keep in mind when linking content is that the map or map package must be an item that you have access to, whether you own it, it's shared with your organization, or it's publicly shared. Also, you will only be able to add linked content after you publish your survey. And once you have added your linked content, it is not necessary to republish your survey. One other thing to note is that all linked content is being added as a base map, so you will be able to add any layers and labels that you need, but you will not be able to interact with the layers. The following list of map types can be added as linked content in Survey123 when using the standard map type. As you can see, some of these formats, like web maps, will only work in an online environment, while some, like mobile map packages, can also be used in an offline environment. As we saw in the demo, any linked content that you add will be available in the Base Map Chooser, along with 6 default Esri base maps. The Base Map Chooser also remembers previous base map selections for each map question. When you publish a new survey from Connect, you may also want to keep in mind a few publishing options. After you hit the Publish Survey button, you will see a window with a few options that you can toggle on or off. One of these options is to create a web map while publishing. If you publish with this option toggled on, a web map will be created in the Survey folder in ArcGIS Online. The web map will contain the survey's feature layer with default symbology and the default Esri base map. This web map will automatically be added to your survey's linked content menu. Another option is to enable sync. This option determines whether sync will be enabled on the survey's feature layer. This is the minimum requirement if you want to download this layer in a map for offline use. Enable sync can also be turned on after the survey is published. In some situations, the survey author may want to set the default base map for a survey. This can either be done at the survey level, which will set all maps in the survey to the selected base map, or it can be done for each individual survey question. To set the default map at the survey level, go to the Map tab in Connect and select the base map that you want all questions to use. This will also set the default map for the inbox, outbox, sent, and overview maps. To set the default map for each question, enter the text map equals along with the item ID or map name in the body Esri style column in the XLS form. Being able to set different defaults for different questions allows you to create base maps that are more specifically customized for each question. Both online and offline maps can be set as a default. For example, in the survey that I linked a web map to previously, the linked web map is available in the Base Map Chooser menu. But I want that map to be the base layer by default. To do this, I can open the survey in Connect, go to the Map tab, and select the map that I want to be the default for this survey. Now I can republish the survey, and once I update the survey in the Field app, all the maps in the survey will now default to my linked web map. Now, if I wanted to add a second geopoint question that I want to have a default base map that's different than the one set in the Map tab, I can specify this in the XLS form. If I add the second map question, I can specify a default map specific to this question in the body Esri style column by entering map equals and then the map name or item ID. I'll set this question to the Esri imagery base map by entering map equals imagery. If I save this and look at my survey form, now the previous question's default map is still determined by the setting in the Map tab, but this question has the imagery base map. Next, we'll go over the different ways to create and deploy an offline map. Creating the offline map can be done with online or desktop applications, and you can deploy the map by copying the map to your survey's media folder, using linked content, or sharing the offline map with all the surveys on your device. The first step in using offline maps in Survey123 is creating the offline map. One way to do this is by creating an offline map area in ArcGIS Online or ArcGIS Enterprise. If you make an offline map area using this method, the online version of the web map must be linked in the Linked Content tab in Connect. And then any offline areas created with that map will automatically be added to the Linked Content menu. You will also want to make sure that all layers of the map, including the base map and reference layers, are enabled for offline use. Another approach to making offline maps is to use ArcGIS Pro Desktop, which has tools to create a map tile package, vector tile package, or mobile map package. A third option to create your offline map is to use Esri Labs Tile Package Creator. After you've created your offline map, the first option to deploy it is to copy the map package file into your survey's media folder and then publish your survey. Any map packages in the media folder will then be available in the survey's base map picker. The pros of this method are that no additional configuration is required for the survey author, and the survey user doesn't have to worry about downloading offline maps because they will automatically be downloaded when the survey is downloaded. A few cons to this method, depending on your offline maps, are that including large map packages will mean a longer time to publish and download the survey. and that more space on your device will be needed to store the map package. Also, if you need to make any changes to the survey, you will need to republish the survey with the new map package. In this survey, I will upload a mobile map package of the Esri campus so it can be used as a base map for my question. First, I'll open the survey files from Connect, find the media folder, and then copy my base map package file into the media folder. Now if we return to Connect and update the form, you can see that the mobile map package is available in the base map chooser. The second method of configuring an offline map is to download linked content. If you add linked content that is in a format that can be taken offline, there is an option to download the linked content from the survey's title page. The linked content formats that support offline downloads are tile packages, vector tile packages, and mobile map packages. Downloading linked content is well suited for a survey that needs multiple offline map areas, and this method also allows multiple surveys to be linked to one hosted map package. One consideration with this method is that since the maps will not be automatically downloaded with the survey, instructions to download the offline map will need to be provided to the person completing the survey. In this survey, I'll download an offline map from linked content. I've already published my survey and linked to a mobile map package file that's hosted on ArcGIS Online. If I go into the Field app and open the survey, there's a Download Offline Maps option on the Survey Overview page. If I download the map, it will be available in the base map picker even in offline settings. The third way to configure offline maps is to share a map package with all the surveys on a device by sideloading a map package. You can sideload a map package by directly copying the map package file to the default map library folder on your device. The full paths for the default map library for each type of device operating system is shown in the image on the lower right and can also be found in the Survey123 documentation. If your device has an SD card, you can also load your offline maps from the SD card. In Survey123 3.12, Android devices support loading offline maps from an SD card when the files are loaded into the SD card folder listed on the slide. This change is in response to how scoped storage is handled in Android 11. A couple advantages to sideloading maps are that the maps can be used by all surveys on the device, and that new maps can be loaded in completely offline environments when they're stored on SD cards. A disadvantage of this method is that you will need to plan ahead for any additional hardware such as SD cards, laptops, or USB cables that you might need in order to load the maps onto the device. As you explore the different ways to configure maps, keep in mind that you can configure the labels for the survey records through the instance name column in the Survey XLS form. This will also control the survey name in the list view of the inbox, outbox, sent box, and overview box. You can also set the default map and zoom level for maps in your survey in the Map tab in Survey123 Connect. And finally, by default, Survey123 uses your organization's base map gallery, but you can also set a survey's base map gallery and default base map to be based on a group. This can be configured in the Settings section of the Organization tab in the Survey123 website. In the next section, Zach will discuss working with external GNSS receivers.
Thank you, Barbara. Now that you have your map configured, let's take a look at using external GNSS receivers with Survey123. The location provided to your device and to your survey can come from many different sources provided your system location provider. This may include a Wi-Fi location, Bluetooth location, cellular location, IP address location, and/or a GPS location. When storing a location in Survey123, by default, a 2D location point is stored as X and Y. However, if you want to store a 3D location point to capture the Z value, you need to set the field type to be a Esri field type point Z. Because all feature layers require a geometry, if you do not have a location and submit your survey, a default location of 00 will be recorded. Survey123 starts requesting the location information from the device as soon as you open the form. If you do not have a geopoint question visible on your form, the first location that the app receives will be used and stored as the location of the survey. If you do have a geopoint question visible, the first position captured will be used and set the location. However, you can interact with the geopoint question to move the marker pin manually or recapture your current location. The first point captured may also be less accurate if the device is cold or doesn't have a valid GPS signal, or is using only Wi-Fi or IP address. Waiting for and confirming that you have a good GPS location is preferable. You can also press and hold the My Location button to get a collection of points averaged, and store the average location calculated from all the points included in that time. There are two ways to connect your device to external GPS receivers, either via a direct application connection or the OS system internal connection. A direct connection is where the Survey123 app is connected directly to the GPS device via Bluetooth, network, or USB connection, and is the preferred way for connecting to a receiver. This means you can interface directly with the GPS receiver and read all of the metadata properties making use of the GPS receiver's full functionality. It's the least complex in terms of app configuration, and using a receiver with SBAS should give a good quality outcome suitable for most GIS work. All metadata that comes with the NEMA sentence will be available to the Survey123 field app. The operating system internal connection means that your receiver is connected to the OS and overrides the device location provider. For this type of connection, no settings or changes are required in the app. Although it doesn't give you all the GPS metadata and full functionality from your GPS receiver output. On iOS, device manufacturers overwrite the device's internal location provider information and have no option for providing GNSS metadata. As a result, manufacturers need to output NEMA sentences over a dedicated channel for use on iOS. Android devices require a mock location provider setup, which we recommend using the manufacturer of your receiver's own app. The manufacturer overwrites the device's internal location provider information and can optionally add extra metadata, more than what you would get from the device's internal location provider. To connect to an external receiver in Survey123 Field app, on the main menu choose Settings, then choose Location, and add a location provider. Choose the type of connection. The most common connection type is Bluetooth, and that is what I will show you here. I'll come back to the other types in this list shortly. I have already paired a receiver with my device, so it appears in the list. Once the receiver is added as a provider, you can see there are a number of settings that can be configured for it. When you return to the list of providers, you can now see it is automatically selected. Let's go back to that list of settings. For each provider, you can modify the name of the receiver you see on the provider page. If you only use one receiver, this might not be necessary. But if you have several units of the same model, you might want to differentiate them with a unique name that identifies them. The alerts given by Survey123 can be tailored to suit your data collection method. If you are walking along not necessarily looking at the screen and you lose connection, an audio or vibrate alert might suit you more than a visual alert. If altitude is an important measurement for you, then setting the antenna height and selecting the method of altitude calculation might be necessary. Take note, some receivers account for this themselves, and indeed can incorporate orthometric models in their own software, meaning the value that Survey123 receives may already be corrected and no further adjustment is required. Going back to the Add Provider page, there were a few other types of connections. A USB connection is common for Windows users. A USB GNSS dongle provides a cheap and easy way to improve location on a laptop or tablet. The network connection opens up an opportunity for much more creative ways of receiving a location. You may have a receiver that is resident on your business network that you can connect to remotely, but more recently, we have found that this is an ideal way to consume the location reported from a receiver in more than one app at the same time. When a receiver is connected to a device via Bluetooth, once an app starts reading data from that receiver, another app cannot. A question we've had is, how can I continue capturing a line feature in Collector while I capture points along a route in Survey123? Using a Bluetooth connection in this scenario results in Collector losing the connection when it goes into background, while the points are being collected in Survey123. An alternative is for Survey123 to connect to a receiver with a network connection, leaving the Bluetooth connection for Collector. A file connection is another clever way to connect to a receiver. Not designed for real-world data collection, instead, this is a great demonstration tool. If you need to demonstrate a survey that is designed to work outdoors with a GNSS receiver at, say, a conference or for your colleagues in the office, record a NEMA file and play it back. Then in your demo, you can capture records as if you were outside. As mentioned earlier, using a direct connection to the receiver allows for high accuracy data collection and storing metadata in your survey to better understand accuracy and quality information. Here is a list of GNSS metadata that can be retrieved from the receiver along with your location when using a direct connection. Position source type, position fixed type, differential age, latitude error, longitude error, geoid separation, h-dot, v-dot, p-dot, speed, vertical speed, direction, just to name a few. If you want to ensure the location captured by the user is within an acceptable threshold and meets all the criteria to be accepted, there are a few ways you can configure your survey to achieve this. Using the body accuracy threshold, you can set the maximum acceptable threshold. Using bind as rewarning, you can set a warning if the criteria is not met, but in this case, submission is still allowed. You can also use the constraint column and constraint messages to pop up an error if the criteria is not met. This will cause the submission to not be allowed until the location is within the acceptable constraint set. You can use a number of different criteria in the warning and constraints, such as horizontal accuracy, connection mode, speed, vertical accuracy, and even the number of satellites used. All of these can be very useful to ensure the most accurate location for the survey is being captured and submitted. To extract attributes from a geopoint object, you can use a pull data function with the property being @geopoint. In this function, you specify the geopoint question name and then the property that you want returned. For example, pull data @geopoint, which has a question name of location and the horizontal accuracy is desired. Here's a short list of other supported properties, but the full list covers much of the GNSS metadata noted previously. Now let's take a look at using a GNSS receiver with Survey123 for a tree inventory. Starting with the XLS form, you can see I have set the body accuracy threshold to 3.8, which will be in meters. The bind as rewarning also has an expression where the accuracy type needs to be GPS, or if no GNSS receiver is directly connected and the location is coming from the device's location provider, the horizontal and vertical accuracy 95% CI needs to be less than 5. The PDOP needs to be less than or equal to 2, and the satellites in use need to be greater than or equal to 5. Otherwise, if these properties are not met, a warning message will appear in the form. Next, the receiver's device name is populated in a text question and displays a relevant group containing a handful of GNSS metadata properties. A few of these properties are the properties used in the body as rewarning above. Switching over to the Field app, at first I'm using my device's integrated location provider. As you can see, when the geopoint populates with my current location, the body accuracy threshold throws an error, stating that the coordinates are not within the accuracy threshold of 3.8 meters, which is set in the XLS form. Opening the geopoint question and selecting the GPS icon also confirms that my current accuracy is 5 meters. We'll select the satellite icon on the top right of the screen to open our current location status. From here, selecting the gear icon on the top right then brings us to the location provider settings. I already have a GNSS receiver connected to my device, so I'll select Add New Location Provider. Then select Bluetooth, and with the Discover option enabled, the GNSS receiver that is already paired with my device displays. Selecting the provider then brings me to the settings for the specific receiver. As shown earlier, from here I can select the Information button and change to the display name of the receiver, as well as view the details of the connection. Next, selecting alerts allows me to enable or disable any alerts as I please. As you can see at the bottom of the screen, the location sensor was connected and is ready for use in the Survey123 Field app. I'll disable the audio alert for now, as the visual and vibrate alerts will meet my needs. Next, I will specify the antenna height of my receiver. Since I have a handheld receiver sitting just off the ground, I will specify 1 foot as my antenna height. Next, I can specify my altitude height as either altitude above mean sea level or height above ellipsoid, as well as my geoid separation. I will leave these default. Backing up to my survey, I can now see that my accuracy is 3.1 meters, which meets my accuracy threshold. Scrolling down, since the device name was populated with the name of my receiver, the GNSS metadata relevant group now displays in the form. Scrolling through it, you can see that the source type, accuracy type, horizontal accuracy DOP, vertical accuracy DOP, PDOP, satellites visible, satellites in use, speed, and direction are all populated. Selecting the geopoint again, and selecting the satellite icon on the top right, we see the location status for our GNSS receiver, such as our latitude and longitude, as well as our altitude, USNG coordinates, speed, direction, accuracy mode, confidence level, and associated accuracies. Selecting the skyplot icon shows you the current skyplot displaying which satellites are in use and which are not. At the bottom of the page, you will see a bar chart that shows you signal strength represented as a percentage for each satellite in view and in use. Selecting the map displays your current location on the map, and the debug page shows your NEMA data stream. Backing up to the survey, we'll complete our tree inventory and submit. For more information on using GNSS receivers with Survey123, please check out our Use a High Accuracy Receiver documentation and Prepare for High Accuracy Data Collection documentation. For visual examples, please check out the GNSS values and location quality expressions sample in Survey123 Connect, as well as Marika's direct GNSS external receiver support in Survey123 as your community blog. Also, please check out our Extract Geopoint Values documentation for a full list of available geopoint properties that can be extracted using pull data at geopoint. I'll now hand it over to James, who will discuss modeling and inspection workflows.
Thanks, Zach. Let's now move into modeling a common field task, an inspection workflow. Asset inspections are an extremely common workflow used across nearly every organization. Some examples that we've seen with Survey123 customers include fire hydrants and other municipal infrastructure, well and other operational machinery, and vehicles such as boats. Just like any other workflow, creating a successful inspection workflow involves a combination of creating a data structure that supports the workflow and designing the form and other information products to make it easy for field staff to conduct the inspection and stakeholders in the office to visualize the results of the inspection. There are two data structures that we typically see used in inspections. The simpler of the two is one where the asset information and the inspection information are in the same table. While this is a simpler design and can work more easily across many different applications, it has some limitations. The first limitation is that users will constantly be editing the primary record of the asset. If the form is not well designed, this may enable unintended editing of asset information, such as the asset location or date installed, in addition to the inspection information. A second limitation is that this structure limits the inspection history that can be stored, typically to just the most recent inspection. Another structure is to separate the asset information and inspection information into separate tables. This creates a series of inspection records, enabling the entire inspection history to be stored. The asset inspection information normally can be joined via a common attribute, like the asset ID, or a database-generated unique key. For maximum form design flexibility with Survey123, we encourage the use of a GUID-based key. There can be some difficulty in displaying the information across tables in some applications, but that can be resolved by creating layer views that join the information together. Just as there are many ways to create the tables, there are also many ways to design the form. When the asset and inspection information are in the same table, Survey123 can easily create a form to modify the existing records or create new ones. In particular, the form will need to have the inbox enabled so that editing can be done out in the field. When the asset information and inspection information are in different tables, the inspection component is placed within a repeat section of the form. This allows for multiple inspections to be present in the form, such as being able to view previous inspections or edit them if allowed. The asset information is also available and displayed in the parent section of the form. This can be read-only or made editable if that is part of the workflow requirements. Another option is to have a form that only edits the inspection information. Because this form doesn't have a repeat section for the inspection, it can be much more flexible, not requiring the inbox or a GUID-based relationship. It will need to have some way to specify which asset is being inspected. This can be done using text entry, barcode scanning, a selection question, or having the value passed in through another application like Workforce. When opened via another application, it is possible to copy additional data from the opening application into the form. After determining the overall structure of the form, we can then apply properties to individual questions or groups of questions to better fit the collection activity. This can include making a question read-only or removing it entirely if it should not be edited, changing the appearance of questions to optimize the layout, and setting parameters for repeat questions to ensure the viewing or editing of previous records. One property useful in making questions editable on initial collection, but read-only when editing, is the mode property that can be retrieved via a pull data function. Finally, as mentioned before, you'll want to enable the inbox functionality to be able to edit the existing features. If you want to edit the existing features in the feature service with the Survey123 Field app, you will need to enable the inbox via the form settings in Survey123 Connect. This will allow the app to query the feature service and load the existing features. As part of this, you can also apply a query expression to restrict which records are loaded in the inbox. You can also control what the field users can do with records, whether they can view, edit, or copy the existing record into a new record as a new collection. The query expression can make use of any fields in the main table of the form, such as a status or last modified date field. You can also bring in the currently logged in user's username by using the $curly bracket username placeholder. When enabled, the inbox will appear on the form's home screen, along with the Collect, Sent, Outbox, and Drafts box. Clicking on the inbox will display the list of features that have been downloaded onto the device, along with the ability to refresh that list. You can view the features in either a list or a map, and then select a feature and open the form. There is one element used in the inbox that we specify in the form XLSX file, the instance name setting. This is the label used in the inbox and all the other boxes to help identify a particular submission. This is an XLS form expression. It can use calculations, including if and other formulas, to create a human-understandable label. Now let's see all of these elements put together to create an inspection workflow. Here we have a map that shows water inspection status. I click on a station and we can view its current status as well as load the inspection history. You can see that this is set up with separate asset inspection tables. And I can confirm that by going to the feature service and see the water station's asset layer and the water sample's history inspection layer in the feature layer. In Survey123 Connect, I'll begin creating a form with the Create a New Survey button and then select using an existing feature service. I'll find the service that I want to use, in this case the Water Quality Inspection Service, enter the title, and hit Create Survey to create my new survey. Survey123 reads the fields and other information to create the form and Excel file. Let's now do some formatting to the form. First, you can see that we have drop-down lists that take up a fairly large amount of area in the form. We can change their appearance to make them more compact. We also have several questions that we want to be read-only, such as the location. So to start, I'll set the appearance of these selection questions to minimal and Lakert in order to make them a more compact display on our form. Then I'll go over to the read-only column and set the first questions, which should not be changed by the user, to be read-only. I can also rename elements such as labels so that they present a more user-friendly expression. I can then go to the instance name and provide that information from the form that we will use to make the label, in this case the water body name. Saving the form updates the saving the Excel file updates the form, and you can see that the layout has been improved. I'll now go to the options and enable the inbox. Note that when the inbox is enabled and the sent box is enabled, we may not see all of the records appear in the inbox if they are already present in the sent box. To address that, I'll disable the sent box. I'll also add in a query filter to limit the records that were retrieved to just Montgomery County, our area of operation. Now with our form configured, I'll publish. You can see that we are using an existing URL, so we're not creating a new layer. Once the form is published, we're ready to go out into the field. Now let's look at the Survey123 field app. I've downloaded my form and go to the inbox. I refresh the inbox to view the records that I can edit and select a record. I can view the form data and edit those fields that I'm allowed to edit. In this case, stating that there's a water station advisory and providing the reason as well as the dates. I can then go in and create the new inspection record, recording my inspection for today's date. I can then submit my record, which will send the updated information back to our feature service. Looking at the web app, you can see that the status is updated, changing from green to red, and that I can now show my related records and view the new inspection history. We just started creating an inspection workflow by using an existing feature service and then publishing a form that is designed to edit additional inspection records. This is a workflow that used a single form and a single step. In many instances, the inspection is one step in a multi-step sequence that may involve quality assurance or review, potential secondary inspection or revisits, as well as additional approval stages and reporting stages to view the current status. You can take the basic techniques of setting up an inspection workflow and expand them to support a multi-step process. When doing so, we'd recommend breaking out the process into each individual step and identify what questions need to be answered at this step, who will fill in this step, and what data do they need to answer those questions. When creating a multi-step workflow, it's easiest to start with a form that contains the questions asked in every step. This will ensure the feature service has a field for every question. You can then create an individual form for each step, removing or hiding questions that a user doesn't need to answer at that step, or making a question read-only if they shouldn't edit the data. You should also have a status or other metadata field to be able to identify which step a form is at. you'll be able to load records from the previous step using the inbox. The first form will normally be the initial submittal, the stage at which a new record is created. If you include a status field as part of your metadata, it's best to have it present in this stage as a hidden question to initialize it. Each stage will use the inbox to open up a form for review or editing. Using definition queries, you can restrict the inbox entries to only those at the current stage. Stages after the first can have the status fields shown before the reviewer to move the form to the next stage and provide other review comments. Stages are not restricted to just Survey123 forms. Other applications like Web App Builder and Dashboard can make use of these same fields and stages by using feature layer views that have definitions expressions applied to the view to make it relevant for that particular stage. I'd like to thank you for watching this presentation. If you have any questions, there are many resources you can use. First, the Survey123 Resource Center is a central hub to get the Survey123 application and access the help documentation. We also have several videos in YouTube highlighting common tasks and workflows, and we regularly blog in the Survey123 Esri community group. If you have any questions, feel free to ask them in the Q&A for this session or contact one of our Survey123 experts listed in the session description. After the UC, you can also reach out by asking a question in the Survey123 group in the Esri community. Again, thank you.